Our final lesson in Chapter 6a is 6.3, but we're going to spend multiple days on this. Trigonometric functions of any angle. What we're going to do in this part of the lesson is actually take our SOHCAHTOA, like all of our definitions for our trig functions, and actually put them on a coordinate system. So we're not just going to draw a triangle, but we're going to look specifically into each of the 4 quadrants. When we do that, we'll have reference angles that help us create our triangles. And when we define our 6 trig definitions, sometimes our answers will be positive and sometimes they will be negative. If we look at this definition chart on the left in blue, definitions of trig functions, you'll notice now as you rotate into a quadrant, we're still going to have an initial ray and a terminal ray, but we're going to have an ordered pair that puts us in quadrants 1, 2, 3, or 4. And the radius that would be on the circle that contains that ordered pair is now technically the hypotenuse. I know, it looks kind of strange. We have our 6 definitions. We've got sine, cosine, and tangent. And then we've got those reciprocals, cotangent, secant, and cosecant. They're still technically related to opposite hypotenuse, opposite, and adjacent. But now we're looking at the x-coordinate, the y-coordinate, and then that value of r, which is the hypotenuse. You're either going to rotate by a degree or radian measure, or simply by that ordered pair. So the location of the terminal ray is going to matter. As you plot a point or you know a trig definition, you know you're going to have a terminal ray in any one of the 4 quadrants. What you'll then do is connect that ray to the closest x-axis, and that will create your triangle. We need to be particular if x or y are negative, because that will affect some of our answers. Notice, for example, in the definition, sine equals y over r. That is technically the same as opposite over hypotenuse when we draw our picture. And then cosine would be adjacent over r, which is the x. Tangent would be opposite over adjacent, which is y over x. So it really will still match SOHCAHTOA. It's just going to look different in those quadrants. Okay, so let's see if we can figure this out. Over on the right, do you see where I have the 4 quadrants kind of mapped out? If we take a look at these, on the right-hand side, as you count to the right, x would be a positive direction. But if you count on the x-axis on the left, you count in a negative direction. From the center, if you count up, y would be positive. But if you count down, y would have a negative value. We can use that information to kind of help determine when trig functions are positive or negative. In quadrant 1, we luck out because both x and y are positive. And that makes sine, cosine, tangent, cosecant, secant, and cotangent all positive answers. But in quadrant 2, things change. As you count to the left, that's the x value. So in our definitions, anything that has x in it is going to change sign. For example, we've got cosine, we've got tangent, cotangent, and secant. If x is negative on the left, those terms will all have a negative in the fraction, which means their trig definitions are negative in quadrant 2. The only 2 that are positive are sine, because sine will stay positive on that y value. Notice I'm not really concerned with the r. The r value, that hypotenuse, is always positive. So that actually might be something good to write down over here in this chart. R is the hypotenuse, and it's always positive. So you'll never have to worry about determining what quadrant you're in for that part. Okay, that's really big. Okay, down in quadrant 3, what's unique about that is both x and y are negative. So if you have just one x or one y, the answer will stay negative. But if you have 2 of them, 2 negatives cancel out. That means tangent and cotangent are actually going to stay positive. But notice sine and cosine, secant and cosecant both just have one x or y, and that would make both of their sets of definitions negative in quadrant 3. I know, this is still so much to try to think through, so I'm hoping that this is working a little bit. And with practice, it will. Now that last quadrant, quadrant 4, taking a look at x is positive on the right, but y is negative at the bottom. Now anything that has a y in it is going to have a negative fraction answer. That means sine and cosecant, tangent and cotangent. But in quadrant 4, when you count to the right, x is positive, making cosine and secant positive values. The chart is really just there as a resource for you to recognize in particular quadrants some values are positive and then some of them are negative. So here's what I mean with an example down below. It says if sine of theta equals 4/5 and tangent is less than 0, find cosine and cotangent. If sine is positive 4/5, that means we could be in quadrant 1 or we could be in quadrant 2. That's where sine is positive. But if tangent is less than 0, that means we're looking for tangent to be negative. And tangent is negative in quadrants 2 and 4. Just using that chart on the right-hand side as a guide. We want these statements to be true at the same time. So what this means is we're going to have to draw our picture where they match, and that would be in quadrant 2. So what you want to do is just draw an XY axis. From the center of our graph, we're going to take a terminal ray and just draw it somewhere into quadrant 2. Doesn't matter where you draw it because we're not exactly sure where it's located. But the rule is you always connect your ray down to the closest x-axis. We have that over here at the top. So I'm just going to pick a point on that ray and draw it straight down to the x-axis to create a right triangle. Now our reference angle is always going to be particular. We always want to draw it in the same location. Our reference angle is also going to connect to the x-axis down here, right by the center of the graph. So there's my theta. So if sine is 4/5, by definition, that's opposite over hypotenuse. We need to figure out the length of the adjacent side, or that x segment side, so that we can determine cosine and cotangent. Here's what's unique about these problems, and this is where it gets a little tricky. If we do a squared plus b squared equals c squared, there's nothing tricky about this part. We'll have a be that adjacent side length, so keep that. And many of you probably already know this answer. We've seen this kind of triangle before. 4 squared is 16, and 5 squared is 25. If I move 16 over, I run out of room, so that's fun. So I'm just going to bring this over here. And we get a squared equals 9. And when you take the square root, a equals 3. But here's what's unique about location on a coordinate system. Remember, in quadrant 2, you're counting to the left on the x-axis. So what makes this unique is that a is not only going to be 3, but the direction is going to make it -3. So this is why it's really important to listen to this video to hear that kind of explanation. Because of direction, we're counting to the left. That means a is going to take on a -3 value. Whoa, okay, once you recognize that, we can determine cosine and cotangent just by applying our definitions. So we know cosine, whoops, that's supposed to be an S, cosine of theta is the same as adjacent over hypotenuse, or x over r. Well, that x coordinate, or the adjacent side, is -3, and the hypotenuse is 5. Cosine's negative in quadrant 2, and we got a negative fraction answer. Cotangent, by definition, is x over y, or adjacent over hypotenuse. And again, the adjacent side is -3, not hypotenuse, adjacent over opposite, sorry. And the opposite side length is 4. So both of our answers are negative for cosine and cotangent in quadrant 2. Here's another interpretation of how to utilize that information up above. It says let -3, -7, that should be a comma, there we go, be a point on the terminal side of theta in standard position. Find the exact values of the 6 trig functions of the angle. Well, we're not given a degree or a radian, we're given an ordered pair. If we graph that ordered pair on a coordinate system, -3, -7 would put us somewhere down in quadrant 3, just somewhere down here. What you want to do then is just take the terminal side, which is just that ray that we drew up above, and draw it somewhere down in quadrant 3. It really doesn't matter, and I'll show you why in just a minute. So I'm just going to draw my ray kind of down here like so, and then I'm going to pick a point on that ray, like we did up above, and the rule is to connect it to the closest x-axis. That means I'm just going to go straight up like so and draw my little right angle in the corner. You always draw your right angle on that x-axis location. And then what I'm going to do is create my reference angle, and that's the other angle on the x-axis like so. So that's where I'm going to put my theta. So you always want to draw a picture something like this every time. Okay, so that -3, -7, here's how we're going to utilize that. Remember, -3 was technically how far we counted on the x-axis. I'm going to label that side of the triangle then -3. And then y is -7. I'm going to label that side accordingly, -7. Now, in order for us to find the 6 trig functions, we need to have all 3 sides to get all 6 of them. We're going to have to do Pythagorean theorem to get the length of the r or the hypotenuse. So if we do a squared plus b squared equals c squared, be careful here. A and b would be the -3 and the -7, and you can write them in either order. But when you square them, they become positive. And if you just type it into your calculator without the parenthesis, the calculator doesn't do the work for you. The calculator gives you a negative answer. Just be mindful of how you type that in to avoid errors in your work. -3 squared is +9, and -7 squared is +49, equals c squared. 9 plus 49 is 58, and that's unfortunate because that's not a perfect square. If we take the square root, we get 58 on the inside of the square root. Now I know 2 goes into 58 29 times. 4 doesn't go into 8, so I think we're out of luck. I think that's going to be that simplified, or 58 I mean. So that's going to be the simplified version for the r value or hypotenuse. And remember, this one's always positive because it's the hypotenuse or that r value by definition. I'm just going to write in then square root 58. Once you know that side length and you know what values are positive and negative, we list out our 6 trig functions just like we did in 6.1. So I'm just going to write sine theta, and that's opposite over hypotenuse, makes that -7 over square root 58. Oh, and then we have to rationalize. So we still have to follow those rules, which just means I'm going to multiply top and bottom to rationalize. And that gives me -7 square root 58 over 58. Okay, well, I'm going to run out of room here too, aren't I? Oh boy. All right, cosine is going to be adjacent, so -3 over square root 58. If you rationalize that, I'm just going to save us a little time here, we would get -3 square root 58 in the numerator over 58 in the denominator. So I'm just going to double underline those so we know that they're different from the fractions. Now tangent, watch this everybody. Tangent theta, if we do opposite over adjacent, we get -7 over -3, but 2 negatives simplify to a positive fraction. That matches up with our definition up above that we said tangent and cotangent were positive in quadrant 3. So I'm just going to slide my work over a little bit to the right so I have more room to write my reciprocal functions. Now the reciprocal of sine is cosecant, so hopefully you have some room to write this down somewhere. I know you can't write off your paper like I'm doing that. So what I'm going to do for the reciprocal is I'm not going to do my final answer reciprocal. I'm actually going to take the initial definition. Cosecant would be r over x, or excuse me, r over y. So that's square root 58 over -7. And then that's already done. Like you don't have to rationalize it if the square root's already in the numerator. So it's kind of nice. Cosine, the reciprocal is secant. And if I take the reciprocal of the original, that's square root 58 over -3. And then the last one, the reciprocal of tangent is cotangent. And for this one, I'm actually going to look right at the answer we got since it was positive, and I'm going to take the reciprocal, 3 over 7. The purpose again of this lesson is to literally just put you in different quadrants and try to understand what values are positive and what values are negative. I have a little homework for you for tomorrow, but this is the only thing you're going to be asked to do. I want you to complete this problem right here and see if you can draw the picture using the 4, -2 as the point on the terminal side. Do Pythagorean theorem to find your missing side length, and then find the exact values of the 6 trigonometric functions. Please complete this for tomorrow, And then what we'll do is we'll add on the second part of the notes for 6.3, day 1.